Hey everyone, welcome to this explainer. Today, we're looking at alternative databases, basically treating data storage like a massive developer's tool belt. Because let's face it, when it comes to modern, high-performance apps, one size absolutely does not fit all. I mean, you wouldn't use a sledgehammer to tighten a tiny screw, right? Well, that same exact logic applies to how we store and manage data in the real world.
All right, let's take a quick look at our roadmap for today. We're going to start by moving beyond relational databases, then we'll dive into NoSQL, cloud databases, spatial databases, in-memory databases, and wrap it all up with making the right choice.
Okay, Section 1, Beyond Relational Databases, the setup.
So, we've got to ask ourselves right out of the gate here, is a relational database always the best choice? Now, for decades, we've relied heavily on those super familiar, strict rows and columns. And hey, they're fantastic for traditional business systems where structure is basically everything. But we have to wonder if that rigid table structure is actually the right tool for every modern, fast-paced app handling massive scale and crazy varied data types. And, well, the short answer is definitely no.
To put it into perspective, traditional relational databases give you incredibly strong consistency and a totally fixed structure. But look at these alternative models. Developers jump to these when flexibility, massive scale, geographic queries, or just pure unmatched speed matter way more than a perfectly neat table. Now keep in mind, these alternative models aren't completely wiping out relational databases across the board. Instead, they're just super powerful alternatives designed for very specific, very demanding needs.
All right, moving on to Section 2, NoSQL, flexibility at scale.
So NoSQL basically just throws those rigid table requirements right out the window. By using flexible schemas, your records literally don't even need identical fields. Your data structure can just adapt and change entirely on the fly. And because it's so flexible, NoSQL systems can scale horizontally across tons of different servers with ease. That's absolutely vital when you need to support massive spikes in traffic or data size, especially when you've got thousands of concurrent users hitting the system at once.
Let's think about how this actually plays out in the real world. A social media platform is like the perfect example. User profiles, posts, comments, likes, they're constantly changing and definitely don't all share the exact same attributes. NoSQL handles these massive volumes of semi-structured data flawlessly. Whether you're using document, key value, column family, or graph models, they're tailor-made for things like e-commerce catalogs where, a t-shirt specs are wildly different from a smartphone's, or for seamlessly mapping out those massive webs of user-friend relationships. But as you know, there is literally always a trade-off in tech. On the plus side, you're gaining this incredible ability to scale flexibly and handle insane traffic growth. But you do give up some of that strict relational structure, along with the ability to run those really complex joins that standard databases handle so easily. Essentially, you're making a calculated bet that schema flexibility is going to matter more for your app than strictly structured transactions.
Next up, Section 3, Cloud Databases, Managed and Elastic.
Simply put, cloud databases completely flip the script on hosting. Instead of worrying about patching aging hardware in some dusty server room, your database is hosted and maintained entirely on cloud infrastructure by a third-party provider. Basically, you're no longer relying on local company or school servers to keep the lights on.
And organizations just absolutely love this setup. It's really a three-step win for them. Step 1, they can offload all that routine, tedious hardware maintenance straight over to the provider. Step 2, they get to tap into elastic scaling, meaning storage and performance can instantly balloon up or shrink down, depending on what users actually demand. And Step 3, they get incredible system uptime and automated backups, which is a massive weight off the shoulders of their internal IT teams.
Now, while they're absolutely brilliant for hosting SaaS products, school platforms, and huge online booking systems, you really got to weigh the trade-offs here. Things to think about include potentially high long-term recurring costs, a total dependence on the internet just to access your data, and of course, strict security and data compliance. You really have to do your homework to make sure the provider actually meets your organization's legal and security requirements.
All right, let's jump to Section 4, Spatial Databases, Mapping the World.
So a spatial database is this incredibly cool tool built specifically to understand physical space. It's completely optimized to store and query geographic or geometric data. We're talking specific latitudes, longitudes, exact coordinates, and even complex shapes like points, lines, and polygons that map out rivers, land boundaries, or city buildings.
Think about it like this. When your favorite food delivery app needs to figure out exactly which driver is closest to your house, it doesn't just use basic math.
It runs a spatial query. It actively checks real-world routing in overlapping areas to find nearby objects in literal milliseconds, which, ensures your food arrives hot and the driver doesn't accidentally get routed into a local river. This is basically the foundational engine behind urban planning, routing, and environmental analysis.
They are super valuable for geographic information systems, logistics, and things like disaster response. But the trade-off is pretty obvious. They add totally unnecessary overhead and complexity if your data doesn't actually have a geographic element. I mean, you definitely wouldn't use a spatial database to just store a basic list of user passwords. It's a highly specialized tool for a very specific job.
Moving right along, Section 5. In-memory databases, unmatched speed. Okay, so this is where things get really fast. By keeping data primarily in the system's RAM, rather than relying on standard disk storage, the usual performance bottleneck of reading from a disk is completely wiped out. The result? You get lightning-fast reads and writes where response times drop to practically zero.
This is precisely the tool you need when even a millisecond of delay is a total deal-breaker. We're talking about essential scenarios like updating real-time analytics dashboards instantly, caching user sessions so website navigation feels incredibly snappy, powering live gaming leaderboards, or executing high-frequency financial trades where low latency is basically the difference between making or losing money.
But as you might guess, the trade-offs here are pretty massive. Yes, you get immediate instant updates, but RAM is so much more expensive than traditional disk storage. Plus, ensuring your data isn't just permanently wiped out if the server happens to lose power, what we call managing data persistence limits, takes extremely careful engineering. It's basically like owning a high-performance race car. It goes incredibly fast, but it requires constant, careful monitoring.
Finally, Section 6. Making the right choice, the blueprint.
So when we pull all of this together, a really clear golden rule emerges. NoSQL is your go-to for massive flexible scale. Cloud is perfect for elastic managed infrastructure. Spatial handles those complex geographic queries. In-memory is all about that extreme, raw speed. And relational is still the king for strict, predictable structure. The takeaway here is you absolutely must match the nature of your data, your scalability needs, and your budget to the right model rather than just grabbing whatever database you happen to be most familiar with.
So I want to leave you with this thought as we wrap up today's explainer. The next time your digital life just works perfectly, when your favorite app loads instantly, tracks your delivery flawlessly on a map, or scales up to millions of users without breaking a sweat, ask yourself, which of these hidden tools is really doing the heavy lifting behind the scenes? Thanks for exploring these concepts with me, and keep questioning the tech that powers your world.